Oops. Not recording. May I sit for a moment? Is it like command click? Empty class. Call it point. Anybody else need help getting the new class name? We're good? Okay. Good. So, we are writing a class which creates a point in two-dimensional space. So, in effect, what we are going to be doing is reproducing some of the features of the Unity Vector2 class, but nevertheless. So, in order to have a point in two-dimensional Euclidean space, what do we need to know about that point? In order to describe it, what do we need to know about it? Points don't have a magnitude, otherwise they'd be lines. Yes?
Vectors?
Vectors are something, well, if you're... A point in space is defined by? Position as given by? Very good. We need an x and a y coordinate. So, in order to describe the point in this class, we need two variables. We need an x position and we need a y position. So, why is it not allowing me to? For some reason it's just buggy. Alright, so we have a public x and we have a public y. This class now stores enough information for us to be able to describe a point in two-dimensional Euclidean space. But this is a class. They're not just for holding data, they're also for actions. So, what are some actions that we might take on a point in space, in a geometric sense? What can we do to a point? Increase it and decrease it? So, move it around? Yes. We can modify the values of the x, y positions. So, the term is translate. public I have to go to which, sorry? Oh, yeah, click the tab. I'm clicking, but it's just making it go away, not bringing up the settings like it usually does, which is extremely frustrating. So let's think about what a translate operation should do. A translate operation, what should it modify? No? Anybody? Well, we've got two variables, x and y, representing x and y positions. The translate method is intended to move the point. So what does moving the point mean? Yes, so we're going to be changing the values of the x and y variables. Does this method need to return anything? Why not?
How come? Because we've changed already.
Yes, the effect that we are intending to have is on the internal state of the class, not on the external state. So, in that case, yes, we don't have to have a return value from this method. So, what keyword do we use if we write a function with no return value? What type is the return value if there is no type? Seems like a contradiction. Void is correct. We're going to try to avoid the problem. Public void translate. Now, when we are writing a function to move a point, we need to know, well, let me rephrase the question. What do we need to know in order to write code that moves this point? What would be the inputs to our function? What do we need to know in order to move the point? Well, we have the current position, right? The current position is already encoded in the variables of the class. So what do we need to know to move it? Yes? Yeah, we need to know where we're moving it to, right? So, there are basically two ways that you can go about this. Either you say what the new position is and you set it there, or I would say a more natural interpretation of translate would be, this is how much I want you to move by, right? I want you to move up 3 and left 4, something like that. Make sense? So, we need to know delta x and int delta y. Incidentally, quite a big difference between this code and the code that you would find in Unity. Notice I'm using integers here for my coordinate system. Unity obviously uses floats. Because units, like integer means whole unit in Unity. So, now we have a function, we have a method, we know what it's taking in, we know what it's modifying, we know what it's producing as output? Nothing. All we need to do is fill in the middle. So, why don't you folks take a minute or two to fill in the middle of this function with the statements that are required to modify x and y according to the input delta x and delta y values. Only a minute though. Hopefully this shouldn't take you very long. We're kind of reaching all the way back to like our second lesson here. Nothing more complicated than that. In the meantime, I'm going to see if I can turn off the bloody IntelliSense. Stupid thing. There we go. I got it. The class works best when you participate in it. See, that's the version that overwrites the current position of the new position. Right?
Yeah.
That's the other one, that's the first one we talked about. You don't have to draw any upgrades for this. Also, that doesn't even exist in console lab. Oh, don't hard code. First, okay, a couple of questions. Number one, wait. What is the thing that you want to modify? In terms of variables, what's that? Yeah, so the thing on this side of the equal sign is the thing you're modifying. So here you're modifying your input, which probably don't do. Also, you've hard coded a 4 here, but you've made the parameter how much you modify. How much you want to modify. Yeah, so you have to think symbolically. Well, you don't need an if statement for this. We actually, we're not concerned about negative values because adding a negative value just means translating it like backwards, down, or to the good. I think it would be hard to oversimplify this one. Yep. Okay. Yep. So first of all, don't need declared variables. put ints there, that means you're redeclaring the variables, which means you're actually creating a local copy. Notice, when you've got your cursor on this y, it highlights this one. That means it's linked. But if you put an int there, notice it's no longer highlighting it. So that actually breaks the reference between the two of those. You've redeclared it in a local context. So, first of all. Second of all, what is D? Yes. Third, what are 50 and 30? See, you have picked particular values, right? But you should be thinking completely symbolically. Don't pick particular values. Right? Whatever the value of x and y are, you want to modify them by these amounts. You don't want to, like, otherwise you're always just calculating the offset from 50, 30. Right? You want to calculate the offset from anything. Right? So, I think that makes you're most of the way there. So, we want to modify x and y by an amount corresponding to the inputs delta x and delta y. So, it's very simple. X is equal to x plus delta x. Similarly, y is equal to y plus delta y. And that's it. So, we take the existing value of x, we add delta x to it, and we reassign the result back into x. This has the effect of taking x, if we have x at like 3, and we add 7, the new position is 10, which is 3, and you move over 7. Make sense? Good. So now, let's produce a method that reports the state of the point. This will be very useful if we want to do any kind of debugging. So, all I want is a function, a method, which takes the x and y positions. Let's say that the x and y positions were 7 and y is 10, negative 10. I want a method that produces a string like 7, negative 10. That way, I can use that string to print to the console the point so that we can see, so that we can test things and see what's going on. All right? So, we will want to create a new method. A suitable name for this method would be like toString. It will be a public method. What will be the output type of this method? Let's see if someone else can get it. Static? No, static, we haven't talked about static yet. Static is something else entirely. So, of our primary data types, integers, floats, booleans, strings, doubles, which one is appropriate here? What is the type of the thing we are trying to output?
Double?
Double? Why?
Because we're talking about like numbers right now.
This is what I'm trying to output, right?
Oh,
What is that?
float?
It's in quotes. Everything in quotes is string, yes. Although it is true that we are working with numbers, we are trying to produce a string, like we're trying to print them as a string. So, string to string. Is this a reserved word or something? No, that's fine. So, does this method need to take any arguments? Is there any information necessary from outside of the class in order to take the x and y positions and put them into a string for us? How many people think yes? How many people think no? Okay. A few people think no. And no is correct. Very good. All of the data that we intend to print is already contained in the class. Therefore, we don't need any information from outside the class. Therefore, we don't need to provide any arguments. Now, we need to return the string. We need to produce a string that looks like this and returns it. Note, do not hardcode 7 and -10 anywhere. I want you to substitute the values that are already in those variables. Basically, in this entire example, if you touch any of the numeric keys, except to put a symbol in, and not a number, basically if there's a number in this entire thing, you're hard coding values and you shouldn't be. Right? Everything should be dealt with symbolically. No numbers. Alright? So, write me a string. Write me a return statement which outputs a string looking like this. And just for added whimsy, you can use whatever form of bracket you like. You don't have to just use round braces. This one shouldn't take very long either. Okay. How many people still working on it? Okay. So, return, opening brace, concatenate the value of x, concatenate comma, concatenate y, concatenate closing brace. There we go. Make sense? So, now that we have something to do with the point, we can try using it out a bit. Let's create 2 points in space. Let's create 2 instances of the point class. We create a new point, A, new point, there we go. This line creates a new instance of the point class and names it A. We can now say A dot x is equal to 7, A dot y is equal to -10. We can say console dot write line A is equal to A dot to string. Except, that's with a lowercase, that's going to be a bit confusing. Okay, do me a favor. Change this lowercase t in your point class to an uppercase. Don't worry about the fact that it underlines it in green. So now, if we run this, we see we get A is equal to 7, -10. So running the toString method generates the appropriate string, outputs it. Make sense? So far so good? Now let's try out our translate method. A dot translate for 6. Then let's print the state of A again. And you can see that after we have translated by 4 and 6, our x coordinate has increased by 4 and our y coordinate has increased by 6, which is precisely what you would expect. Make sense? Good. Question?
Let's see your example page.
Yeah, that's the S. That's the thing that's in scope.
Yeah, there is. No, I didn't do,
Oh,
did you?
This may be what they mean when they say they no longer has these choice.
You don't have time.
You have two
time.
options.
What?
You have to do, you have to line, you have two places. Yeah.
One,
This is our easy shit, I can do that.
back here. Two, you can do the same thing.
Like the network.
If you make a new script object inside of the assets folder, that will, any classes that you put in there will be automatically loaded as classes in the same way here. Basically,
He's gonna say
you just
no.
put the contents of program files inside of the start method of a script attached to an object. That will run it, and just exchange console.writeline for
Yes, sir.
debug.log,
What'd you do?
and it's the same thing.
You said you guys were working together. Yeah? In the group chat today?
Oh,
With
actually,
right?
They just add me to.
oh wait, actually here, let me see this one.
Oh, yesterday you said. Check.
Maybe if it's,
Yeah. What?
it's command S. Oh, it's gone away. Yeah, so, namespaces are a little bit strange.
Not probably, but it's something else.
So, what that means is you're not properly oh, okay, this is actually quite a useful one for you, right? You have named the function, you have not called the function. Yeah. Which should indicate to you that C# is comfortable handling function names as references to functions. Right? So here's one for your brain. You can pass functions as arguments to functions. That's what we call functional programming. Yes. Because you're missing a plus sign. Point is not loaded. Oh, let's, nothing will work if we don't get that work. Let's take a look. Cat. Actually, if I may make a suggestion, that will work for now. In future, the convention is that class names should be capitalized. It distinguishes them from our regular areas. Yeah. That's a pretty universal convention across most programming languages, actually. Good. Everything works? Point is not working. Well, right there. So you've got it named class 1. So unfortunately, point doesn't exist. It has to be class 1. Then everything will append to class 1. Once you do that, everything should work. Once again, you have to be consistent with your references. Everything working?
The translates references.
Point does not contain a definition. Well, it should. Will it? Yeah, you've got Transalti.
Oh,
One thing that everybody should become as you go through your programming journey, you will become better spellers. Just because you're now being punished for it in a way that you never were before. Okay. So, so let's do one more method, just while we're on the subject. Let's do scale. So the definition of scale is to scale a point relative to the origin, right? So if I were to, let's say I take a square on the axes. Squares can be defined by 4 points, of course. And I scale that up by 2. I end up with something looking about like that. Every point has been moved further away from its from the point it started by a factor of 2. And if you take a look at what's going on with the coordinates themselves, scale, all that's doing is it's multiplying each of the coordinates. So if this was x, y before, it becomes 2x, 2y up here. Now we want to write a scale method which takes in an arbitrary scale, a scaling factor, right? So, this will be another public method. Is there any output from this method? Are we changing any data that is external to the class? Mm-hmm. Yes or no? Yes? No? No is correct. All of the thing we're modifying is the coordinates of the object, so we don't need to do anything outside. So what keyword do we use to indicate that there is no return value? Void is correct. You'll pick an appropriate function name, scale. Now, what information do we need in order to write a scaling method? What do we need to know in order to scale the point? Yes, the scaling factor. Yes. So, I already did the curly braces. So, we need the scaling factor. Now, and I'm leaving translate in frame very intentionally, please take a moment to fill in the guts of this method. Write some program which takes the point and scales it by the scaling factor. So you see my little diagram, sort of with the squares? So basically that just means it makes more sense if you take it like this. Imagine you have a shape, like a circle, right, relative to the origin, and you wanted to scale that up by a factor of 3. You'd end up with something like that, right? If this point was 1, 1, 4, after scaling up by 3, your new point will be 3, 3. That's all scaling means. It gets a little tricky when it's relative to a point that's far away from the origin. But yeah, that's basically you got it. So, class is almost over, so I will give the answer for this. X is equal to x times factor. Y is equal to y times factor. There we go. Okay. I think that's about as much as we're going to be able to do today. Thank you very much for your time and attention today, folks. And we will resume on Tuesday.